Hello, viewers. In today's session, we are going to discuss an important concept in three-dimensional geometry. And here we are going to discuss the concept of image of a point in a line, right? So here we'll see this concept with the help of this problem where we have to find the image of this point, that is 1 comma minus 4 comma 2 with respect to this line whose equation in symmetric form is given as x minus 1 over 1 equal to y plus 1 over minus 2 equal to z plus 2 over minus 3, right? So here we'll see how we can find out the image of a point with respect to a line with the help of the concept of direction ratios, right? And here we'll treat this equation of line as a mirror, right? So let us see how we can calculate the image of the coordinates of the image of this point with respect to this line with the help of the concept of direction ratios. So let us first draw a rough diagram for this problem. So here we have this line. Suppose this line is our line L. So here we have the line L, and here we have the point, this point, that is 1 comma minus 4 comma 2. Let us call this point as a P, right? So now if this line is taken as a mirror, then the image of this point P lies over here, and here let us take the image as the point Q, and let us take alpha, beta and gamma as the coordinates of the image of this point P, right? So now if we join these 2 points like this, then this line is perpendicular to this line, that is the given line L. So PQ is perpendicular to L. So here we have 90 degrees, right? So now let us call this point as M, which is the point of intersection of this line PQ and this line L, right? So here M is the midpoint of this line segment PQ, because point P and Q are equidistant from the line L, because P is the point whose image is Q, and this line L acts as a mirror. So this point M is equidistant from the point P and Q. So let us now write the coordinates of this point M using the equation of the line L. So here we are given the equation of line as x minus 1 over 1 and y plus 1 over minus 2 and z plus 2 over minus 3. Now this point M lies on both the lines, that is the line PQ and the line L. So here let us introduce a scalar lambda, which is a real number. So let us use the concept of the general point lying on a line, right? So the coordinates of the point M are now given by here in terms of lambda. So x minus 1 over 1 is lambda, y plus 1 over minus 2 is equal to lambda, and z plus 2 over minus 3 is equal to lambda. So from here we can now write x is equal to lambda plus 1, y is minus 2 lambda minus 1, and z is minus 3 lambda minus 2, right? So for some value of lambda, this coordinate represents this point M. So the coordinates of the point M for some value of lambda are given by lambda plus 1, then minus 2 lambda minus 1, and here we have minus 3 lambda minus 2. So now the next step is to get the direction ratios of this line, that is PQ, right? And this line PQ is perpendicular to this line L. So now the direction ratios of PQ can be obtained by taking the difference of these two coordinates, because if we take this coordinate as x1 y1, say z1, and this coordinate as x2 y2 z2, then the difference of the coordinates gives us the direction ratios of PQ, right? Because we know that the direction ratios of a vector or a line are given by the difference of the coordinates when the 2 points are lying on the line or on the vector, right? So here we have the direction ratios of PQ as x2 minus x1, y2 minus y1, and z2 minus z1. So we have here x2, y2, z2 as lambda plus 1 minus 2 lambda minus 1 minus 3 lambda minus 2, and x1, y1, z1 as 1 minus 4, 2. So we have lambda plus 1 minus 1 minus 2 lambda minus 1 plus 4, and then minus 3 lambda minus 2 minus 2. So we have lambda, and then we have here minus 2 lambda plus 3, and here we have minus 3 lambda minus 4, right? So these are the direction ratios of PQ, and the direction ratios of the line L are given by 1 minus 2 and minus 3, right? And now we'll use this condition, that is PQ is perpendicular to L, to get the value of lambda. So once we know the value of lambda, we can easily find out the coordinates of the point M. So now PQ is perpendicular to L. So the dot product of these two direction ratios must be equal to 0, because we know that if we have two lines and their direction ratios are A1, B1, C1 and A2, B2, C2, then their dot product is A1, A2 plus B1, B2 plus C1, C2 should be equal to 0. So this is known as the condition for perpendicularity of two lines or two vectors. So here we have a1 b1 c1 as lambda minus 2 lambda plus 3 and minus 3 lambda minus 4, and a2 b2 c2 may be taken as 1 minus 2 and minus 3. So we have now a lambda minus 2 lambda plus 3 minus 3 lambda minus 4, and the dot product with this direction ratios, we have 1 minus 2 minus 3 should be equal to 0. So now we have lambda times 1, then we have minus 2 lambda plus 3 times minus 2, and then we have minus 3 lambda minus 4 times minus 3 is equal to 0. So now this is a linear equation in lambda, and let us solve this equation to get the value of lambda. So now we have here lambda, and here we have plus 4 lambda minus 6, and here we have plus 9 lambda plus 12, and this is 9 lambda plus 4 lambda plus 1 lambda is 14 lambda, and here 12 minus 6 is plus 6, and from here we have 14 lambda is equal to minus 6. So lambda is minus 6 over 14, so this is minus 3 over 7. So now we have PQ perpendicular to L. So due to this condition, we have obtained the value of lambda as minus 3 over 7. So let us substitute this value of lambda in the coordinates of this point M, which is the midpoint of PQ. So taking lambda is equal to minus 3 over 7 in the coordinates of this point M, we have here minus 3 over 7 plus 1. Then we have minus 2 minus 3 over 7 minus 1 and minus 3 and minus 3 over 7 minus 2. So now we have here minus 3 plus 7 over 7, and here we have 6. Minus 2 times minus 3 is 6. Then we have here minus 7 over 7, and here we have 9 and minus 14 over 7. So now we have here 7 minus 3 is 4. So 4 over 7, this is minus 1 over 7, and this is minus 5 over 7. So the coordinates of the point M are given by 4 over 7 minus 1 over 7 and minus 5 over 7. So now we can find out the values of alpha, beta and gamma using the coordinates of the point P, which are already given 1 minus 4 2, and we have just found out that the coordinates of M are given by 4 over 7 minus 1 over 7 and minus 5 over 7. Now M is the midpoint of the line segment PQ. So here we have now say this is P, that is 1 minus 4 2, and M is given by 4 over 7 minus 1 over 7 and minus 5 over 7, and Q is alpha, beta and gamma. So here applying the concept of midpoint formula, so the coordinate that is this M is given by 4 over 7. The x coordinate is given by the mean of these two coordinates, that is 1 plus alpha over 2, and similar is the case with y and z coordinates. So we have here minus 1 over 7 is equal to minus 4 plus beta over 2, and then we have minus 5 over 7 is equal to 2 plus gamma over 2. So now if we take this coordinate as x1 y1 z1, and this coordinate as x2 y2 z2, and this coordinate as x y z, then according to the midpoint formula, x is given by x1 plus x2 over 2, y is y1 plus y2 over 2, and z is z1 plus z2 over 2. So now from these three equations, we can easily find out the values of alpha, beta and gamma. So now from this equation, we have 1 plus alpha is equal to 8 over 7. So alpha is 8 over 7 minus 1, that is 8 minus 7 over 7, that is 1 over 7. So alpha is 1 over 7. Now from here we have minus 2 over 7 is equal to minus 4 plus beta. So beta is now minus 2 over 7. Taking minus 4 to this side, we have plus 4. So we have minus 2 plus 28 over 7, that is 26 over 7. So here we have beta as 26 over 7. And from this equation, we have 2 plus gamma is equal to minus 10 over 7. So gamma is minus 10 over 7 minus 2. So we have minus 10 minus, here we have 14, and here we have 7. So this is minus 24 over 7. So here we have minus 24 over 7. So the coordinates of the image of this point P are given by 1 over 7, 26 over 7, and minus 24 over 7. So now here we can also find out the length of this perpendicular, that is PM. So PM is the length of the perpendicular drawn from this point P to this line L. So using the distance formula, we can find out the length of PM. So here we have the distance formula, that is x2 minus x1 square plus y2 minus y1 square and z2 minus z1 square. So now PM is given by here 1 minus 4 2, and M is given by 4 by 7 minus 1 over 7 minus 5 over 7. So now we have the square root, and we can take this point as x1 y1 z1 and this point as x2 y2 z2. So we have 4 over 7 minus 1 square, and then we have minus 1 over 7 plus 4 square, and then we have minus 5 over 7 minus 2 square. So this is now 4 over 7 minus 1 is minus 3 over 7 square, and here we have 28 minus 1, that is 27 over 7 square, and here we have minus 14 minus 5, that is minus 19 over 7 square. So now we have here PM is equal to this is simply 9 over 49, and here we have 27 square is 729 over 49, and then we have here 19 square is 361 over 49. So now we have here 9 plus 729 plus 361. So here the denominators are same, and here we have 49. So now if we add these three numbers, we have 361, 729 and 9. So this is 9 plus 9 18, 18 plus 1 is 19, 6 plus 2 8, and then we have 9, and here we have 10. So we have 1099 over 49. So now let us reduce 1099 over 49 to its lowest term. So we can now divide here 1099 by 7. So we have 7 times 1. Here we have 39. That is 7 5 is 35, and then we have 4. So this is 7, and here we have 7. So the perpendicular distance, that is PM, is given by the square root of 157 divided by 7 units, right? So viewers, this is how by the concept of direction ratios and using the condition for the perpendicularity of two lines, we can find out the coordinates of the image of a given point with respect to a given line.